Overview. The RJ is fitted with Sunstrand APS 1000 APU, located in a fire-resistant titanium box under the fin. The APU supplies electrical power via an AC generator to Channel 1 and Channel 2. Channel 1 has priority in the air. The APU is also used to supply air for flight and ground use. It is usually used for air conditioning, particularly on takeoff and landing, to allow the engines to produce maximum power if required. General description. The APU is a self-contained gas turbine engine which is controlled from the APU panel by the pilot. Access for maintenance and servicing is through a large door under the unit. The air intake is on the left side of the fin. The exhaust is on the right to avoid ingestion of exhaust gases. Fuel for the APU is drawn from the left inner feed tank. The APU will start normally using suction feed. The left inner fuel pump is used when AC electrics are available. APU starting. The APU requires a 24-volt DC supply from the aircraft battery. This is the minimum requirement for starting and control. Alternatively, any AC source may be used to start the APU, but via TR1 only. If an AC source is not available, a suitable external DC source may be used to power the start bus only. The batteries, however, must remain on to power the control circuits and fire protection. The APU generator. On the ground, the generator supplies AC1 and AC2 and has priority over external AC. In flight, it can only supply AC1 or AC2. In the event of a double generator failure, it will supply AC1 only. APU air. Air is supplied via the APU air valve for air conditioning, the primary use, and other services which are covered in the air supplies module. If the APU generator is used to start engines, APU air must be off. This is to prevent the APU shutting itself down due to over-temperature. APU auto shutdown. The APU is protected both on the ground and in the air by a series of auto shutdown features. Additionally, an APU fire will shut the APU down on the ground only. This feature permits the flight deck to be left unattended for short periods on the ground. If the fire warning comes on in flight, the APU would remain running until shut down by the crew. On the flight deck, The APU may be shut down by the Start-Stop switch on the APU panel. On the ground only, the APU over-speed switch on the ground test panel may be used. Alternatively, when the aircraft is on the ground, one of two emergency shutdown switches can be used to shut the APU down. These emergency switches are located in the air conditioning bay and next to the refuel panel. If one of the external emergency switches is used, the next action must be to go to the flight deck and place the Start-Stop switch to stop. This is to prevent the APU automatically restarting the next time power is applied to the aircraft. There is also a customer option that will sound an external horn until the APU switch is placed to stop. You should now have an understanding of the features of the APU. The next lesson takes you through external checks. External checks. On completion of this section, you will be able to carry out the external checks associated with the APU and be able to identify problems which require further investigation. You need to check the condition of the APU door and ensure that it is closed and secure. Next, check the APU and pack exhaust on the right and the APU intake on the left side of the fin. They should be clear. Finally, check the fire bottle thermal relief indicator. It should be green. Should you find a problem with any of the components you have checked, call an engineer. That completes the external checks. The next lesson takes you through the normal operating procedures before, during and after flight. Normal operations. In this section, we will work through the normal operating procedures related to the APU. The main panels used are APU, electrics, engines and air supply. Pre-flight checks. Check that the APU generator is in the on position. When the APU is started and APU power is available, the APU generator will automatically power the aircraft busbars. The integrity of the fire detection system must be checked by pressing the APU Fire Test button on the overhead ground test panel. This test must be carried out before the APU is started. If the APU is running when this test is carried out, it will shut down. Before APU start, APU air must be off. The APU valve not shut annunciator should be checked to make sure it is out. On the fuel panel, the left inner fuel pump is selected on. The bulk on the APU Start-Stop switch is released and the start position selected. The Start Power On annunciator on the engines panel will light. The APU fuel valve annunciator on the APU panel will also light briefly as the fuel valve opens. The APU RPM is checked to ensure that it increases smoothly. At 50% RPM, the Start Power On annunciator goes out. As the APU accelerates, the EGT gauge is checked to ensure that the start limitation of 1032 degrees Celsius is not exceeded. The APU Power Available annunciator will light approximately 3 seconds after 95% RPM is achieved. The APU generator automatically provides power to the buzz bars. This is confirmed by ensuring that APU generator offline and all of the buzz bar warnings are out. If air conditioning is required, APU air may be selected on. To avoid thermal shocks to the APU, you would need to wait for a minimum of 1 minute after the APU Power Available annunciator lights. The APU air and both packs must be selected off when using the APU generator to start the engines. This will prevent overload and auto shutdown of the APU. When external AC is used to start the engines, the APU generator must be set to off reset, so that only one power supply is connected to the aircraft. The APU air and packs may be left on. Although the APU is supplying both packs in fresh mode, it is normal to operate with a single pack in recirculation mode whenever possible. This reduces load on the APU and helps to prevent mist from the air conditioning vents in very humid conditions. That completes the pre-flight checks for the APU. Now it is your turn to complete the 5 pre-flight checks by working through the instructions on the following pages. On the electrics panel, check the APU generator is on. Check the integrity of the APU fire detection system. On the air supplies panel, check to make sure that APU air is off and that the APU valve not shut annunciator is out. Start the APU and check all indications are normal. Select APU air on. You have now completed the pre-flight checks for the APU. The next section will deal with the checks you would need to perform in flight. In the air, after takeoff, all engine airs are selected on and the APU air is selected off. A check is made to ensure that the APU valve not shut and APU non-return valve leak annunciators are out. The APU may then be shut down using the Start-Stop switch. If APU air is not required for landing, the APU need not be started. That completes the in-flight checks for the APU. Now it is your turn to complete the 4 in-flight checks by working through the instructions on the following pages. Switch all engine airs to on. Switch APU air to off. Check that the APU valve not shut and APU non-return valve leak annunciators remain out. Switch the APU Start-Stop switch to stop. You have now completed the in-flight checks for the APU. The last section of normal operations takes you through the post-flight checks. Now it is your turn to complete the 4 in-flight checks by working through the instructions on the following pages. Switch all engine airs to on. Switch APU air to off. Check that the APU valve not shut and APU non-return valve leak annunciators remain out. Switch the APU Start-Stop switch to stop. You have now completed the in-flight checks for the APU. The last section of normal operations takes you through the post-flight checks. Post-flight. If the APU was not started in the air, it may be started after landing to provide air conditioning. When the APU is no longer required, APU air and the packs are switched off. The normal method of stopping the APU on the ground is by testing the APU overspeed circuits by pressing the APU overspeed button on the overhead ground test panel. This confirms that the APU overspeed protection circuit is working. After checking to ensure the RPM and EGT are reducing, the APU Start-Stop switch is selected to stop. Finally, the left inner fuel pump is selected off. That now completes the lesson on normal operations. The next lesson takes you through abnormal operation procedures for the APU. Abnormal operations. On completion of this section, you should be able to understand the most likely causes of problems which affect the APU and be aware of the reasons which lie behind abnormal checklist actions. Non-return valve leak. If a non-return valve leak occurs, it could mean that the APU is in danger of having engine bleed air forced down the APU ducting against the flow. This could cause the APU to surge and possibly cause damage. The APU air must not be used whilst the annunciator is lit. The APU generator may be used without restriction. Should the non-return valve leak annunciator subsequently extinguish, APU air can be used again. APU auto shutdown. The APU will automatically shut down to protect against damage following certain malfunctions. These apply equally to malfunctions on the ground or in flight, with one exception. What is the exception? These malfunctions are signalled by illumination of the auto shutdown annunciator on the control panel. The only action required of the crew is to place the APU start-stop switch to stop and the APU air switch to off. The APU must not be restarted. That now completes the lesson on abnormal operations. The next lesson presents details of limitations affecting the APU. Limitations. The APU starting envelope is 0 to 20,000 feet. If the APU is required in an emergency, a start can be attempted above this altitude, but may not be successful. The EGT limit is dependent on the operational mode. Under continuous operation, the maximum EGT is 718 degrees Celsius. During starting, the maximum EGT is 1032 degrees Celsius. If the APU generator is used for engine start, what must we ensure? The APU has a maximum speed limitation of 106.5%. An overspeed shutdown will occur above this speed. Attempts to start the APU should be limited to a maximum of 3 start attempts at 1-minute intervals, ending with a 5-minute cooling period. 3 further attempts may be made, and then the entire cycle can only be repeated after 30 minutes. The APU generator limitations are: additionally, APU air can be supplied up to a maximum altitude of 15,000 feet. That completes the APU module. Now try the module test.